Hello. Hello. Hi everyone. Good afternoon. I am Abhideep Sahu, and today I'm going to take your class. So, okay, yeah, right. So today we are going to do applications of derivatives. I hope all of your preparations are going well for your JEE Advance. Just a minute, I'm hearing some equal. Just rectify it. Okay. So Before starting the class, can you please or can everyone please tell me whether my voice is audible and the video is clear on the screen? I'll just launch a quick poll. Please respond it. Okay, I guess we one has joined yet, but we'll start with our class. So fine. So we'll talk about applications of derivative. All right. I hope the screen is visible to everyone. Okay. So application of derivative. This particular chapter is like the questions which we expect from application of derivatives are usually from easy to moderate category. They are easy to solve, and the concept is very limited. Like very small concepts are being used. Mostly, it's a use of derivation, differentiation only. And yeah, like it's not. It's pretty much easy. Yeah, right. So there are majorly three subparts of application of derivative. The first one is tangents and normal. The second one is monotonicity, and the third one is maximum minimum. Okay. We'll try to cover as much as we can for today. I'll discuss the theory in brief, whatever important parts we need to know before solving the questions, and then we'll do some previous year questions of this choice topic. Okay. So we'll start first with the tangents and normals, and as we all know what tangents and normals are, right? So for any curve, like if we start, tangent is basically the derivative of a function y is equal to fx at any point, right? If this is a point, then tangent or the slope is represented by f dash x, right? So basically, tangent for writing the equation of a tangent, there are majorly 2 points required. One is the slope of tangent. Second is your point of contact or point on tangent. Okay. So if a function is given y is equal to fx, right, and we need to draw a tangent to this particular curve, what we'll do the step one is we find the slope dy by dx, which is equal to f dash x, which is also equal to the slope of the tangent. So we'll find f dash x first, and then the equation of tangent can be written as y minus y1 is equal to m times x minus x1, where x1 comma y1 are the points on the curve, are the points where the tangent is being known, points on curve where the tangent is drawn. Tangent is drawn. Okay. So this is how we'll find the equation of a tangent. Next comes the normal. So normal is basically what a line perpendicular to the tangent. Right? This is a basic definition of a normal. Like whatever a line is perpendicular to a tangent, it's categorized as normal. So what information do we get from it? That the slope of normal will be minus 1 times of the slope of the tangents. Why? Because if two lines are perpendicular to each other, their slope m1, m2 is equal to -1, right? So by using the same information, we find the slope of the normal. And for equation of normal, again, it's a straight line, right? So we need to find two things: the slope and the point. So slope of the normal can be found using -1 by fx. -1 by fx. -1 by fx will be the slope of the normal, which is -1 by m. And equation of normal can be given as y minus y1 is equal to -1 by m x minus x1. Okay. So this will be your equation of normal at a point on the given curve. Okay. Is it up to this point? Is it clear? Please. If you have any doubt, any issue, please let me know through the chat section. All right. Fine. So we have talked these are the two basic things which we need to know for in tangents and normal. The next parts come angle between the curves. Like they'll give you two different curves, f and g, and they'll ask the angle between the curves. Now the only thing which we need to realize or visualize or understand here is the angle between the curves basically requires two things. The first thing is intersection of the curves, right? Unless the curves are going to intersect to each other, there will not be any point of intersection or the angle between them. Second thing is, if you look here, these are the two curves which I have drawn, like I'll draw again. These are the two curves, curve 1 and curve 2. Okay, if they are being for getting the angle between them, the only thing which we need to realize is the angle between the curve is nothing but the angle between their tangents. Angle between their tangents at the point of intersection, right? At the point, obviously, at the point of intersection. So whatever tangent we can get at the point of intersection, whatever slope we are getting, for the angle between them, we'll find the here m1. This will be m2, and the angles will be, this angle may be theta, so this angle will be pi minus theta. Are you getting all the up to this, right? So angle between the curves is basically the angle between the tangents, and for angle between the tangents, we need to find the slope of the tangent at the point of intersection for both the curves, curve 1, curve 2, and then we'll use the R formula. Tan theta is equal to mod of m1 minus m2 upon 1 plus m1 m2. This is the general formula which we have already studied in straight lines and in so many places. The angle between the curves is given by m1 minus m2, curve, straight lines, or whatever. m1 minus m2 upon 1 plus m1 m2. Okay. Now the point which we need to keep in mind here is this is a modulus value. So mostly it will always give you an acute angle between 0 to 90 degrees, right? Now the question is, sometimes what happens when we solve the question, a particular question in the given exam. Let's say we are getting, by using this formula, we are getting angle to be 30 degrees. Okay, and whatever options are given in the question are all angles are obtuse angle. So can you think why is it happening so? How you are getting a acute angle as your answer, and the options are given for only for the obtuse angles. Basically, if you look at these lines again, the angle can be both, right? It can be theta, it can be pi minus theta as well. Who knows which angle the person is asking for, right? So it will be our prime duty to always check that whether in the given question theta is asked or pi minus theta is asked. Okay, so if you're getting 30 degree, also do check for 180 minus 30, there is 150 degree in the answer. Okay, if it's a multiple choice question, then both 30 degree and 150 degree will be correct. If it's a single choice question, then either the 30 degree will be given or 150 degree. 30 will be that's that I'm taking as an example. Okay, so always do check for angle and 180 minus angle to get your answers right. Good. So can we move ahead? Right. So for solving such questions, there will be three steps for this particular questions. Step 1, you need to find a point of intersection first. In most of the cases, they might give you point of intersections, But if they don't, and if they just simply ask the angle of intersection of the two given curve is, then the step 1 is find the point of intersection. Step 2, find the slope of both the curves at the point of intersection. Step 3, tan theta is equal to m1 minus m2 divided by 1 plus m1 m2. I hope I am clear up to this point. Okay. Is there any issue, any problem you guys have? Okay, great. Sure. So we'll move on to the last tiny bit of this particular theory, the tangential normal. It is orthogonal curves. So orthogonals, we all know orthogonals means perpendicular. So two curves are said to be orthogonals when they intersect at 90 degree at each point of intersections. This is very important to give in. Okay, then only the curve will be orthogonal. So how do we know whether the curve is orthogonal to or not? Simply, there are two ways. One is m1 m2 is equal to -1. Like you are getting finite values for m1 and m2 and their product is -1, then the curve is 90 orthogonal, or either you are getting m1 as plus minus infinity, so obviously m2 will be 0. Okay, sometimes like what it may happen now, like the tangent or the slope is a like this. Suppose this is a curve, so tangent could be a straight vertical line as well, right? So the two cases are possible. The case one where m1 m2 both are finite values and the product is -1, m1 m2 is equal to -1, then we can say the curve and the curves, the tangents are orthogonal, hence the curves are orthogonal. Second, we are not getting a definite value, we are getting in like plus minus infinity for one slope. So obviously the second slope, if it comes to be 0, then obviously it's a typical case of y-axis and x-axis, right? So it can be that as well, right? Am I clear? Okay, fine. So far in tangents and normals, we have learned three things. The first one is tangent. So tangent is basically what? dy by dx at any point, whatever point they are asking you for. Okay, so the slope will be there. Always remember, whatever the slope you are getting at that point for the particular tangent, the same slope will continue from minus infinity to plus infinity for that line. Okay, the slope do not change for a given line at any point. Once it is defined, it is defined, right? So that is first thing is tangent. For normal, what we need? -1 upon slope of the tangent. Okay. Then we studied about this angle between the curves. That is tan theta is equal to m1 minus m2 upon 1 plus m1 m2. And lastly, we like the sub part of angles. That is orthogonal curves. The two curves are said to be orthogonal when they intersect at 90 degree. So, okay. So for 90 degree, again two conditions: m1 m2 is equal to -1, or either m1 is plus minus infinity, m2 is equal to 0, or m2 is plus minus infinity, m1 equal to 0. Whatever, like what that depends on which slope you're calling m1, which slope you're calling m2. Okay. So we are clear up to this point. Great. So we'll do one question based on this particular concept, slope and normals. The question is given, like it's a previous year question. It is given as if the normal to the curve y is equal to fx at the point 3, 4 makes an angle 3 pi by 4 with positive x-axis, then f dash of 3 is equal to what? Basically, you are given some curve, okay, and there's a normal to this curve y is equal to fx at point 3, 4. There's a normal, okay, fine. And the normal is making 3 pi by 4 angle with the positive x-axis. So can you imagine that the slope of the normal, basically it's given as tan 3 pi by 4. Like if this is the normal, so can I say m normal is equal to tan 3 pi by 4? Because whatever line it is, if this is x-axis, this is y-axis, right? If it is making 45, 3 pi by 4, and 135 degree, so this is also the slope of the line. Slope of the line, also the slope of the normal. That's what I said. Once the slope is defined for the line, it is defined for all. From minus infinity to plus infinity. So what we are given here is slope of the normal as tan 3 pi by 4, which is nothing but -1. Okay. Now the second thing which we need to understand is it is asking f dash of 3. The point is same, 3, 4, and f dash of 3 is slope of the tangent at point 3, 4, right? F dash is the slope of the tangent. So can you tell me if mt is the slope of the tangent, mn is the slope of the normal, is equal to -1, right? mt slope of normal is -1 equal to -1. Minus and minus gets cancelled both the side. So what we get, m slope of the tangent is equal to 1, and which is nothing but f dash of 3, because f dash x is the slope of tangent, and at 3, 4, f dash 3 is nothing but the slope of the tangent with x value equal to 3. So our answer to the given question is f dash 3 is equal to 1. Is this clear to everyone? I hope everyone is getting what I'm trying to explain here. Great. So shall we move on to the next part? Recently, there has been very less questions from the normals, and mostly the questions come from maximum, minima, and monotonicity. So we will now move on to the monotonicity part. Okay. Cool. So let's move on to the monotonicity. Is the screen visible to everyone? Okay, fine, great. So we'll start the monotonicity now here. What monotonicity is basically is, see, mono means same, same. Tonicity means trend, tone, trend, or something of it. So basically, monotonicity is same trend, same tone. A graph or a function behaving in a single pattern throughout its journey from minus infinity to plus infinity. So that's what monotonicity means. Monotonicity means following a same pattern throughout. Okay. Now there are two subparts of monotonicity, subparts or say types, whatever you want to call it. The first one is the increasing function. The second one is a decreasing function. As the name suggests, increasing function is what? As the x values increases, the y values also increases. Okay. Or we can say f of x1 is greater than f of x2 for all x1 greater than x2, where obviously x1 and x2 belongs to the domain of function. Okay, so this is increasing function. So increasing functions, we can I'll brief this because we just need the crux of to solve our questions. Okay, so increasing function is as the x value increases, the y value also increases. Okay, the other way to find this is, it's very simple. Why the derivative is associated with this particular concept is this. Suppose this is our graph. Okay, simply increase like a graph in which x value and y values are increasing with each other. If you draw a tangent at any point on this graph, any point, you will observe that the tangent is always in this particular fashion, which is 0 to 90 degree. The slope is 0 to 90 degree, and the slope is always positive. And this is why we say if the dy by dx of the function is positive, the function will behave in the monotonic increasing way. As the slope is always positive, hence the function is always increasing. Now there are two things: strictly increasing. Strictly increasing means at no point the two values will get equal. Like nowhere two values equal means fx1 or fx2 will get equal. Simply increasing it, they can be equal at some point, and the graph could be like this. If you look at it, see there are two graphs. One is this. The other graph is this. So if you look at this graph, at no point the two values are same. So this is strictly increasing. And at this point, you can see there will be 2 or 3 values where the graphs are same, and this is called increasing. Okay. Mostly, they hardly pay attention to increasing, or like they do, but if it is asking for increasing, we simply go for f dash x greater than 0. That's it. Okay. Now, so if we look at the what we need to do to solve the questions, so we need to just find a derivative of the given function. We need to find a derivative of the given function. If the derivative is positive, we'll say the function is strictly increasing. End of the story. Okay. Contrary to that, the decreasing function, as the x increases, the y value decreases. The graph will is shown in this particular way is the sliding down the type of graph. Okay, as the x value increases, the y value also decreases. The y value decreases, so graph is sliding down. Now, if we associate this particular thing with the derivative, we look at this particular graph. That derivative at each point is of the fashion. The angle of or the slope is between 90 and 180 degrees. So the slope is negative at each point. Hence, we say dy by dx is less than 0 for strictly decreasing or for decreasing functions, basically. Okay. The same concept is here, strictly decreasing and decreasing. If two values at two different points are same, then we can say decreasing. And if it's not same, then strictly decreasing. Okay. Again, what we need to remember is just find the derivative of the function. If dy by dx is less than 0, it's strictly decreasing. End of the story. Okay. So what we need to keep in mind in the for solving monotonicity questions, if f dash x is greater than 0, it's an increasing function. If f dash x is less than 0, it's a decreasing function. Okay. Now you need to keep remember one thing in mind, that a function may not be increasing or decreasing throughout its domain. It can be, cannot be, like there are both the scenarios possible. But in a particular restricted domain, it can be increasing and decreasing. For example, I'll draw a graph for you. Look here. A general polynomial. Okay. So as such, this particular function is increasing, decreasing, everything. So we cannot categorize the whole graph for to be increasing or decreasing function. But from this point to this point, this is increasing. From here to here, see here it is increasing, it will decrease. So if they are mentioning a given interval x1 say x2, and in that particular interval, if the graph is increasing or decreasing showing the characteristic, then we can say, yeah, fine. In this particular interval, the graph is increasing or decreasing. Are you getting my point? A function may not be increasing or decreasing throughout its domain, but part-wise it can. Okay, fine. So moving on, what we need to do is fine. One more thing which we need to keep in mind is the f dash x can be 0 for strictly increasing and strictly decreasing function at discrete points. Okay, why I'm saying this? If this is the graph, at a single point it can be 0, and again it can be like this. Okay, there are no multiple points or a range of points where the function is 0. This is a single point. So still this can be an increasing function, no issue with that. Okay, so this is just a statement which we need to know. F dash can be 0 for SMI or SMD, the strictly monetarily increasing and strictly monetarily decreasing function, but only for discrete points, not in intervals. Okay, if it's a increasing or decreasing function, it can be 0 throughout an interval, no issue with that. But if it's increasing or decreasing at just a single point, that too discretely, then we can say, yeah, it's monetarily increasing. Example, this again 0, then 0, somewhat like that. Okay, so this is an increasing, strictly increasing. Cool, great. So now we'll move on to the question. This much information is good enough to solve the increasing decreasing functions questions. So we'll move on to the question. The first question is the function fx 3x minus 7 into x power 2 by 3 is increasing for all x line, and we need to find the interval of x where this function is increasing. So how do we solve it? I'll solve this question for you, then you'll get the idea how do we proceed with the questions. Okay, so we are given fx is equal to 3x minus 7 x power 2 by 3. Now if we need to check for increasing or decreasing function, what we need to do, we need to find the f dash x. That is the step one. F dash x we find. So this is a simple derivation question, derivative question. So how do we differentiate it? Using the product rule. So I'll keep the first function 3x minus 7 as it is. Differentiation of the second function will be 2 by 3 x to the power 1 by minus 1 by 3, 2 by 3 minus 1 by 3, and a minus also comes outside. Plus, sorry what? Oh, sorry, minus 1. Plus differentiation of the second function 3x minus 7, that is 3 into x power 2 by 3. Right? Now we'll rearrange the terms. So what we'll do? Okay, this is what? See, 3x minus 7 into 2 divided by 3x power 1 by 3 plus 3x power 2 by 3. I'll take the LCM. F dash x is equal to 3x minus 7 into 2 plus x power 1 by 3 plus x power 2 by 3, that will be x. So this will be 9x whole divided by 3x power 1 by 3. I'll open the brackets and simplify it further. So I'll get f dash x is equal to 3 to 6 plus 9, 15x minus 14 divided by 3x power 1 by 3. Okay. Now this is the derivatives of fx. So next step is we need to plot the critical points on the number line. So the critical points, can you tell me what are the critical points of this? 14 by 15 and 0 is the critical point. So 0 here, 14 by 15. Okay. Next step is BB curve method. Yaad hai? Like, do you remember the BB curve method? We'll mark the first territory as positive, the second negative, positive. Right? And since we need to find the increasing regions, so we'll pick the regions where the derivative is positive. So that we'll get from here and here. So ultimately the answer is x belongs to minus infinity to 0. 0 cannot be included. Union 14. Oh, sorry. Union 14 by 15 to this is a answer. So this is the interval where this given function is increased. Clear? How do we proceed? We find the derivative, then we find the regions where the derivative is positive or negative, and then we pick the regions of our interest. In this particular question, it was asked for the increasing function, so we put the regions of positive. Clear? Great. Cool. So we'll move on to the next question now. This is the question. Let hx is equal to fx plus f square x plus f cube x for all x belonging to R. Then comment on the monotonicity of hx in reference to fx. Means with the help of the behavior of fx, you need to assess the behavior of hx. Fine. So for assessing the hx, first we need to find the derivative of hx. Right? I'll give you 1 minute. Please solve it, and then I'll solve it. Okay. Please try this question once. Find the derivative of h dash x. Anyone getting this? So what we are giving? We are given h of x is equal to f of x plus f square x plus f cube. अभी तो सब क्वेश्चन लिखा है. You can try. I'll wait. Few more seconds, then I'll try. Then I'll solve it. Okay. Yeah. So step is to find the h dash x. So this will be f dash x plus 2 fx dot f dash x chain rule, right? Plus 3 f square x f dash x, right? This is what we'll get here. Okay. Now I'll take the f dash x common throughout. F dash x has been taken common. Then what we are left with? 1 plus 2 fx plus 3 f square x. Now, as such, we cannot comment on this particular, what do you say, expression. So we'll try to rearrange a few things and see what can we do. So if you look inside the bracket, there's a square term, there's a single term, and there's a constant term. Does it look like somewhat like a plus b whole square? So the same thing which we'll do here. We'll take the 3 common, like it will be easy then. 3fx, I've taken 3 common. So inside we are left with x square x plus 2 times 1 by 3 fx plus 1 by 3. Right? Done? Now 3 f dash x f of x plus 1 by 3 ka whole square. So this will give us what? F square x plus 2f by 3 plus 1 by 9. So I'll like 1 by 3 was already there, and I'll subtract 1 by 9. Now it is balanced. Next step, 3 f dash x fx plus 1 by 3 ka whole square. 1 by 3 minus 1 by 9. 3 minus, so this will become 2 by 9. Okay. Now please pay attention to the details here. This value is positive. This value is positive, obviously. Squaring is being done. This value is again positive. So the only thing that can change sign here is positive or negative is f dash x. And this is what for h dash x. So can you realize that here the function h dash, the sign of h dash is totally dependent on the sign of f dash, right? So we can say h dash x will be increasing if f dash x is increasing, right? If f dash x is positive, then h dash x will be positive. Hence, hx, sorry, not not f dash, but hx. I did a small mistake here. It won't be h dash x. Sorry, it won't be. Yeah. So hx will be increasing if fx is increasing. Yani if f dash x is positive, then h dash x will be positive. Hence, hx is increasing, and hx will be decreasing if fx is decreasing. So this is how the function hx will be dependent on fx. This is what we need to assess. The options were, like, I did not write the options here, but options were somewhere like there. This was a multiple correct type of questions. One option was hx increasing if fx is increasing, hx is increasing if fx is decreasing, hx is decreasing if fx is decreasing, hx is decreasing if fx is increasing. So obviously these two options will be correct. If fx increasing, hx increasing. If fx decreasing, hx decreasing. Clear? This was a good question to solve, right? So can we move ahead? Great. So now we'll take the another question here. Okay. This is what? Yeah. So we are given that the real number k for which the equation 2x cube plus 3x plus k. I'll write the equation for you. We have to check 2x cube plus 3x plus k equal to 0 has two distinct roots in the interval 0 to 1. Has two distinct roots. Okay. So we have to check for this particular equation for having two distinct roots. Now, the first thing is this is a cubic. So what they are expecting is that the function might be like of this type. Sorry, here and this, or somewhat like maybe not this. No, not this. Sorry. Mm, somewhat like what? This way. Either way, doesn't matter. Basically, they want two distinct roots. Okay. So step one, we'll differentiate the function. This is what f of. So we'll find f dash x, which is what 6x square plus 3. Okay, we got f dash x is equal to 6x square plus 3. Now, if you closely observe, like first thing is why did we go for f dash x? Because if it is asking for roots, then obviously since it's a polynomial degree, obviously the slope will change the sign. So let us assess from the slope point of view, whether it's positive and negative, how many times have we seen in the sign. Okay. Now, since we differentiated fx, we are getting 6x square plus 3. Now the thing is, 6x square is always positive. Obviously, बात है 6 positive है, x square positive है, 6 into x square is positive. Plus, we are doing something addition, and that value is also positive. So can we say that f dash x is greater than 0 for all values of x? It isn't even getting 0. Negative to do negative is the farthest story here. It's always positive. So if a function is always positive, can we say that the function is strictly monotonically increasing? So the function will be of this form, increasing function. So if a function is increasing function, please tell me how many times the function will cut the x-axis. Obviously once only. So if it is cutting the x-axis only once, how many distinct roots are we getting? Forget about the distinct roots. We are getting only a single root. So the answer to this question is no values of k. This is the answer. That for no values of k, there exists two distinct roots of the given equation, because it's a monotonically increasing function, and hence there will be maximum at most only one root. You got it? How we took monotonicity into play in this particular question? They asked us to assess whether a particular function has multiple roots or not, and we thought of checking it with the help of slope of the function at different points. If the slope is changing again and obviously the function, like from positive, if it's going from positive side to negative side, and again it's changing somewhere, then we can say like okay fine, somewhere it might cross 0 as well. But for us, what we got is f dash x is greater than 0, and hence the function is monotonically increasing, hence it will have at most one. Clear? Great. So we'll move on to the next question now. The question is given is if fx is equal to x e power x 1 minus x, then fx is increasing, decreasing. You have to check for increasing or decreasing. So we'll follow the same steps. Okay. Step 1, differentiate. So we have fx is equal to x e power x 1 minus x. Chain rule, product rule, both will become in use here. So we'll find f dash x. So f dash x is equal to e x 1 minus x. First function x is differentiated plus x as it is, e power anything will remain as it is. And now the chain rule, the power will get differentiated. So this is x minus x square. So we'll get what? X, this is x minus x square now. So 1 minus 2x. This is what we are getting. Okay. Now what we'll do, we'll take the e power x common. Sorry, e power x 1 minus x common. In the bracket, we are left with 1 plus x minus 2x square. This is what we are left with, a quadratic. I'll take the minus also common so that the quadratic looks nice to us. E power x, because the first coefficient is negative, it kind of create troubles to us, right? So I take the minus sign outside, then we are left with 2x square minus x minus 1. Right, next step we will try to solve the roots for the roots of this equation. So roots will be this is for the roots. Okay, I'm solving for the roots. Roots will be x is equal to b plus minus root over 1 plus 8 divided by 4. So x is equal to 1 plus minus 3 by 4. So what we are getting, f dash x is equal to minus e power x 1 minus x, and this is x minus 1, 1 plus 4, and 1 minus 3 minus 1 by 2, x plus 1 by 2. This is what we are getting here. Okay, now obviously we will plot the critical points on the number line. So this is our number line. The critical points here are 1 by 2, sorry, minus 1 by 2 and 1. Okay, and since both are numerator, so inclusive. And now the most important part, VB curve method. We'll proceed with VB curve method, right? So this here, this I'm talking about only this values. Okay, only the blue underline part. This will be plus, this will be minus, this will be plus. Okay, but for f dash x, we have a minus already multiplied now. So these signs will change to themselves. So this will be minus, this will be plus, and this will be minus again, and this is for f dash x. Okay, so once we arrive here, we need now we'll check with the options. So b and c will be straight away rejected because the function is not showing same behavior throughout the domain. So b and c are rejected. Now for the region minus 1 by 2 to 1, minus 1 by 2 to 1, the value of the f dash x is positive, hence fx is increasing in minus 1 by 2 to 1. Answer. Is it clear? That's how we do it. Whenever we are asked for monotonicity, we simply differentiate the given function. We plot the critical points on the number line. We check for the signs of the f dash x, and then we check if it's positive, the function is increasing. If it's negative, the function is decreasing. Always keep a check on the minus sign. It will create trouble every time. So be very vigilant when you solve with minus sign. Done? Can we move ahead? Great. So now we'll move on to the next question. Let me just change my sheet. Okay. So this is the next question for us. Just a minute. I'll just. So we are given. Check monotonicity of fx is equal to x cube minus 3x square plus 5x plus 7. We need to assess the monotonicity of this particular function. So step 1, again the same, differentiate. Fx is equal to x cube minus 3x square plus 5x plus 7. Find f dash x. Find f dash x. F dash x will be what? 3x square minus 6x plus 5. Great. Now we need to find the critical points or the roots of this particular equation. So let's check for the discriminant. What will be the discriminant? First, let's check now whether the roots exist or not. So the b square, yani 6 square minus 4 times 3 times 5, which is 36 minus 12 5s are 60. That is minus 24. If d is less than 0, if d is less than 0, so this function, like now, the two things to observe: the coefficient of x square is positive, and D is less than 0. So will the graph of f dash x always be above x-axis? Will it be? Right? Coefficient is positive, so graph will open upward. D is less than 0, graph will never cross the x-axis. The graph will always be above the x-axis. Hence, the graph will always be f dash x is always positive for all values of x. Is it? So if a function is all, if the derivative is always positive, what can we comment about the function? It's strictly increasing for all x belonging to R. So the given function is monotonically increasing for all the values of x. Clear? Does anyone have a doubt? Okay. That's why the function is always increasing. Fine. The next question, we can move ahead, right? Cool. So next question, okay, this is maximum minima question. We'll come back to this later. First, we'll go and look at some brief theory of maximum and minimum. Okay, so we can start, right? So maxima and minima, basically, whatever theory that, again, this is a very tiny part of the theory. We just need to know two things: that how do we find a particular, whether at a given point some function is going for a maxima or minima. Okay. So what we'll do for a given function, the first thing is we need to identify the critical points. Critical points are the points where the function, the f dash x, is either getting 0 or not defined. Okay. These are defined as critical points. So for a given function, step 1, find f dash x. Once you found the f dash x, check for 0. Then whatever values you are getting, these are the possible points. These are the extremum values. Okay, these are the possible points where the function may get maximum or minimum. Okay. Step 2, like as I said, the step 1 is, sorry, I'll change the color. Okay. Step 1 is find f dash x equal to 0. You will get possible points of maximum or minima. Step 2, check for double derivative. If f double dash x is greater than 0, then there will be a minima, concave up. If f double dash is less than 0, then there will be maxima, concave down. And if f double dash is equal to 0, test fails. We cannot comment. As simple as that. Okay. So two things we need to do. Step 1, find the first derivative and equate it equal to 0. So whatever values possible values of x you are getting, those are the possible value points of maxima or minima. We don't know as of now whether that will be maxima or minima. Okay. For checking whether the function that values are maxima or minima, what we'll do, we'll find a double derivative. Okay. If f double dash x is greater than 0, then that x value is the point of minima. If f double dash x is less than 0, then that point is the point of maxima. If f double dash x is equal to 0, we cannot say. The test fails. Clear? Now the second thing which most commonly comes in the exam, like this particular point, maxima and minima, is favorite of all the exams. They ask many questions from maxima and minima. Okay. So the other thing which more often comes in the exams is geometry or application based questions of maxima and minima. They'll give you a certain shade, they roll the shade into cylinder, cone, sphere, something. They ask you to maximize the area, the minimize the area, or they'll do variety of questions using maximum. That they give a function, they ask you to maximize it, to minimize it. Always keep in mind wherever the maximum, minimum, or extreme, like these words are coming, greatest, largest, smallest, whatever. Step 1 is differentiate. Write the function, differentiate it, maximize it, minimize it, check. That's it. End of the story. Okay. So whenever you get a question and it's asking for maximum, the area is maximum, the volume is maximum, the length is maximum, or certain function is maximum, certain function is minimum. Step 1, write the function, the given information in the functional form. Step 2, differentiate it, equate to 0. Step 3, check whether the maximum or the minimum values are asked. Clear? We'll do the questions and then this will get clear to everyone. So we'll straight away move to the questions now. Okay. So the first question that we'll look into is this one. Again, it's a previous year question. Yeah. So let f is defined from R to R as fx is equal to mod of x plus mod of x square minus 1. The total number of points at which f attains either a local maxima or minima is. Basically, हमको ये जो function like what basically this function which we are given is fx is equal to mod of x plus mod of x square minus 1. Okay. We need to find how many maximum or maximas or minimas this particular function has. So, like there are two ways to do it. First, we need to simplify this function. We need to get rid of this mod. And mod changes its values across its critical point where it gets 0. So, what are the critical points here? 0 and 1 and also minus 1. There are 3 points. Remember, x square minus 1 ka mod hai. So x is equal to plus minus 1. So we have 3 critical points here, right? So we'll find the and we'll simply draw the intervals. First interval will be x is less than minus 1. Okay. If x is less than minus 1, then what we'll get function as this. I'll change the color for now. So mod of x, this will be positive or negative? Obviously negative. X square minus 1, let's say minus 2 square 4 minus 3. This will be positive, right? Plus x square minus 1. So this is x square minus x minus 1. For second part, x minus 1 to 0. So what we will get? Again, less than 0, this will be negative again. Also, say 0.5 when 1 by 4 minus 1 negative. So this will also open with a negative sign. So we'll get minus x square plus 1, which is minus x square minus x plus 1. Clear? Next interval, 0 to 1. Okay. So here fx will be now 0 to 1. So this is now positive. The first term is positive, but the second term will again be negative because 1 by 2 square minus 1, that will be minus 3 by 4. So bracket will be open with a negative sign. So this will be x minus x square minus plus 1, which can be written as minus x square plus x plus 1, right? And the last for x greater than 1, what we'll get? Fx is equal to, this will be positive. The first bracket is positive, and also the second bracket will be second modulus will be positive. So what we'll get? X plus x square minus 1, which is nothing but x square plus x minus 1. So now the thing is, we got 4 definitions of the fx. We need to find a possible point of maxima minima. So first method is start differentiating all the functions one by one, equate them to 0, find the and you will get the possible values of maxima and maximum or minimum, right? But since here the function is also changing the definition, we also need to look at the points where the function is changing the definition. Okay. So this can be a bit lengthy process. What is the smaller or the efficient way to do this particular question is, if you look at the 4 functions, all the 4 functions are quadratic, right? And somehow we can draw a qualitative graph of these functions altogether, right? So let's draw the graph and maybe then we can get some idea. So I'll draw the graph for these functions. First part, x square, like this is minus 1, this is 1, okay, this is 0. So when x is less than minus 1, x square minus x minus 1, x square, the coefficient is positive, x square coefficient is positive, hence the parabola will be having a upward opening, so somewhat like this. qualitative graph only. Okay, from -1 to 0, -1 to 0, the graph is minus times this, sorry, the coefficient of x square is minus, so this will be downward opening parabola, right? The value at x is equal to 0 is +1, and value at x is equal to -1, x is equal to -1 is again +1, so graph will be somewhat like this. Okay, from 0 to 1, again minus x square and a downward parabola, again at x is equal to 0 the value is +1, and x is equal to 1 the value is again +1, so we'll again get a graph of like this. And the last part, upward opening parabola, the graph will be like this. So now can you please tell me how many points of possible maximum minimas we are getting here? 1, 2, 3. These are also the points of minimas, right? Where the definitions are changing. In the neighborhood, they are the minimum values. So how many points? 5. This is your. See, if you'll go by the differentiating method answer, you will get the answers. But I guess that will be a little lengthy process as compared to this drawing graph, because here the graphs are very simple. Like we need to draw the qualitative graphs only to assess whether we're getting maximum or minimum. Okay, so this can also be a method to solve the questions where we'll write the definitions of the function, and if possible we'll draw the graphs and assess. If it would have asked for the values, then probably we would have gone for the differentiation method. But since it only asks for the number of points, so I guess this is a better method. Clear? Are we good here? Okay. Now we'll move back to our question. Question we have already left in the previous slide, right? So we'll go and solve that question first, then we'll come back. Okay. So this was the question, right? Let Px be a real polynomial of least degree. This question I'm talking about. Okay. So let Px be a real polynomial. Okay, fine. Of least degree. Great. Which has a local maximum at x is equal to 1 and a local minimum at x is equal to 3. Okay. Then the further information we are given is P of 1 is equal to 6, P of 3. Okay, I missed this value. Give me a second, I'll just check. P of 3 is, just give me a second, I'll just check this value. Give me a second, I'll just find the value and come back. P of 6, right? P of 1 equal to 6 and P of 3 equal to 2. Sorry guys for this interruption. By mistake, I forgot to write down. So P of 3 is equal to 2. Sorry. So yeah, we'll continue. Okay. So we are given P of 1 is equal to 6 and P of 3 is equal to 10, and we are asked P dash 0, the value of P dash 0. Okay. So we'll solve. So now the thing is, here it is given has a local maxima at x equal to 1, local minima at x is equal to 3, and the function is a polynomial of least degree, which means no roots are being repeated. So we'll simply write f dash x is equal to say some k times x minus 1, x minus 3. Do you agree with this particular notation, this particular expression? See, x equal to 1, x equal to 3 are the values where the function is getting maximum minima, right? So these are the values where the function will get 0, its derivative. And also, since we don't know what constant would have been there, that got like maybe we have sent to 0. So for that, to accommodate that, we took k. So f dash x is equal to k times x minus 1 into x minus 3. Now we'll integrate this function and we'll get fx. So fx will be this will be what, k times x square minus 4x plus 3. So we'll integrate this k times x cube by 3 minus 4x square by 2 plus 3x plus c. Right? Constant of integration. Right? Is it clear? Now we'll use the two informations which are given to us to find the value of k and c. So I'll simply write here. We have fx is equal to k times x cube by 3 minus 4x square by 2 यानी 2x square plus 3x plus c, and the information which we have is f of this is p function. I'm sorry, this is basically p dash and p. So p of 1 is equal to 6. P of 1 is equal to 6, which implies k times 1 by 3 minus 2 plus 3 plus c. I'll rearrange and then we'll is equal to 6. So what we'll get, 3 minus 2 1, 3 minus 2 1, 3 1 is 1 4. 4k by 3 plus c is equal to 6. This is the first information, first equation, and p of 3 is equal to 2. So we'll get what, k times 3 cube 27 by 3 minus 3 square 9 to 18 plus 3 3 is a 9 plus c is equal to 2. Not 3 1s are 3 9s are 9 plus 9 18, 18 minus 18 0. So ultimately we get c is equal to 2. Once we get c is equal to 2, what we'll get k is equal to, this also implies k is equal to 6 minus 2 into 3 by 4, which is 3. So p dash x is what, 3 times x minus 1, 3 times x minus 1 and x minus 3. And we have what value we are asked? We are asked p dash of 0. So p dash of 0 is what? P dash of 0 is 3 times 0 minus 1, 0 minus 3, minus minus gets converted to plus 1, and 3 into 3 9. So p dash of 0 is equal to 9. This is our answer. Clear? Was it a easy, like this was an easy question, right? We just need to assume that p dash x is k times x minus 1, x minus 3. It's already mentioned it, so it's a function of the least degree. So take the least possible degree that is possible. So x minus 1, x minus 3. Okay, since these are the points of maximum minima, hence the function will be 0 at these points, and so k times x square minus 4x plus 3, px is equal to k x cube by 3 minus 4x square plus 3x plus, this is after integration. Then we use the given two informations to find the value of k and c. P of 1 equal to 6, p of 3 equal to 2. Once we get the value of k and c, we again find the value of p dash x, which is 3 times x minus 1, x minus 3, and then p dash 0. So 3 into 0 minus 1, 0 minus 3, minus minus plus 3 into 3. 9. This is our clear. Is there any doubt? Can we move ahead? Cool. So we'll move back to the previous question, which was in October. So we completed this particular question. Now we move on to this one. So yeah, let's read the question. This is the application of geometry based question, and these types of questions are very common in the examinations. Okay, so we'll solve this one. A box is made with a square base and an open top. Okay, square base and the top is open. The area of the material used is 192 square centimeters. If the volume is to be maximum, then the dimension of the box are. First thing is draw a rough sketch. Visualize what it is given in the question. So some kind of square base is there. Okay, this is a square, assume it. And a box is being made. Okay, the box is like there's a material on all these sides basically, except the top side. Top is open. Okay, so now what we need to do is we'll assume the base to be of side A. Okay, and the height to be H. Okay, and now we'll utilize the given information. So what information is the area of the material used? So the base and the four sides, right? These four sides and the base, this comprises of the total material used to make this box, because the top is open, right? So the area will be this 192 square centimeters will be corresponding to what? The base and the four sides. First thing. Now the area of the base, like the total area. Okay, so area of the base is A square, since it's a square, so A side into A side, A square. Okay, and for these four sides, the height we have assumed to be H, and the base length is A. So the area of this side, basically this side, is what? A into H, and there are four such sides. So A square plus 4 times AH. This is equal to what? 190. Is this clear? Clear or not? So now what we'll do is simply rearrange, express one in terms of other. So what we'll get? H is equal to 192 minus A square upon 4A. This is the relation which we are going to use now. Okay? H is equal to 192 minus A square upon 4A. Next, we'll move to what? Now, volume for this particular box is what? A into H. What is the volume of a cube? Length into breadth into H. Length is A, breadth is A, height is H. So, A square H is the volume. Please substitute the value of H from equation 1. So, this is what? 192 minus A square upon 4A into A square. Clear? So this A to this A gets cancelled. Ultimately, we get 192A minus A cube divided by 4. This is the volume of that particular box. Now for volume to be maximum, what I told you, maximum, minimum, largest, smallest, whatever terms come differentiate. So we need to differentiate, and only the variable is A here. So dV by dA is 192 minus 3A square upon 4. And to maximize or minimize whatever, the step is to equate it equal to 0. Simplify it. 192 is equal to 3A square. A square is equal to what? 3 6 4 64. This implies A is equal to plus minus 8. Now, obviously, the side has to be positive only, because a negative side, box of negative side does not make any sense, right? So, what we will do, we'll simply take A is equal to 8. A is equal to 8. Put it in the equation 1. So, what we'll get? H is equal to 192 minus 64 upon 32, which is what 6, I guess, right? 6 minus 2, which is 4. So the dimensions are 8, 8, 4 centimeter. Answer. Is it clear? See, ideally we could have gone and checked for double derivative as well for plus and minus 8. But logically, if we see it's a side, it's a length, so it cannot be negative, right? So it has to be positive 8. So that's what we simply do. Okay. Now, so taking a is equal to 8, h is equal to 4. The dimensions are 8, 8, 4 centimeters. Clear now? So what we did, we used the given information of area. We found the relation between the two variables we have, h and a. Use the same relation to use it for the third information that needs to be maximized or minimized. In this particular case, maximized. So the volume needs to be maximized. So a square h has to be minimized. We substitute the relation of h in terms of a in this particular equation. We differentiate it. We find the value of a. We back substitute the value of a and found the value of h. Getting the process? Right? Cool. So let's move on to the next question now. This is the question. So if fx is equal to x power 5 minus 5x power 4 plus 5x cube minus 10 has local maxima and minima at x is equal to k and x is equal to m respectively, then the value of 2k plus m. What simple question? Like it's a very simple question. Okay? We are given a function fx. We are given that the function has a maxima and a minima at 2 points. We need to find those 2 points and then we need to find the value of this expression 2k plus. Okay? Steps are simple. Okay. Is it clear now? Is it clear now, Amrita? Okay, fine. So we are given the function fx is equal to x power 5 minus 5x power 4 plus 5x cube minus 10. So what will be the step 1? Differentiate, right? So we'll differentiate it. F dash x is equal to 5x power 4 minus 20x cube plus 15x square. That's it. Now take 5x square common. 5x square has been taken common. So what we are left with, x square minus 4x plus 3. Is that what we get, right? X square minus 4x plus 3. Clear? So this is our f dash. Now the next thing is we need to find the critical points. So critical points is like simplified, factorize this given equation 5x square as it is. So I guess this will be x minus 3 and x minus 1. X square minus 3x. Yeah, this is what we'll get. So what are the critical points we are getting here? 0, 1 and 3. We'll plot that on the number line. 0, 1, 3. Now the baby curve method. We'll start from the rightmost end. Let me just take the different color. This is positive since the power of x minus 3 is 1. So it will change the sign. So this will be negative. This again will be positive and this will be negative. Sorry. Positive. Because 0 ka power even hai. So hence, if you have any doubts, please ask how this particular thing is happening. Okay, don't issue with that. So from 3 like by crossing 3, it's positive to negative. Crossing 1, negative to positive because the powers are 1. Odd powers are there. For crossing 0, the power is even, so sign will not change. With positive to positive. Okay. Now the thing is, right from here you can tell whether which point is maximum and which point is minimum. How? See, this is for f dash x, right? right? So positive to positive, like this may be somewhat like this graph. Here the slope is 0, positive and positive. Fine. Across one, the slope before was positive and the slope later was negative. So is it somewhat like this? Here it is positive, here it is negative, right or no? Wrong. Can we assess this? And for 3, the slope is going from negative to positive. So will it be like that? Here negative, here positive, here 0, at 3, this is 1. So right from here, we can say that point of maxima, yani x is equal to k. So k is equal to 1 and m is equal to 3. We can say directly. And don't worry, if you are not getting it from here, we'll adopt the other way, the second method which we know, which is we'll check for the double differentiation. So let's find f double dash x. Or okay, or f double dash x is what? That differentiate where it is. Yeah, right here. So this is 20x cube minus 60x square plus 15. Sorry, 30. This will be 30. Oh, sorry. Plus 30x. Right? Now we'll take what 10 will come common. 2x cube minus 6x square plus 3x. Okay. Now we'll put the values x is equal to 1 and x is equal to 3 here. F double dash of 1 is what? 2 minus 6 plus 3. 2 plus 3, 5 minus 6 less than 0, maximum. Right? That's if double derivative is negative, we'll get negative. F double dash of 3. 10 times 3 cube 27 to 54 minus 3 square 9 6 are 54 plus 3 9 3 3 is a 9. Positive negative 0, positive greater than 0, minimum. So by this process also we can assess which point is maximum, which point is minima, or we can directly use the our visualization that a graph is going from positive to negative. So maxima and negative to positive, minimum. So finally we got the value of k equal to 1, m is equal to 3. This implies 2k plus m. The value which was sought is what? 2 times 1 plus 3, which is 5. This is your. Is it clear? If you have any doubts, please ask. Is it clear? Cool. Great. Please ask doubts if you have any doubts. Then we'll move on to the next question. Okay. So yeah, this is our question now. I'll ask you to do as a homework. We have one more question. We are left with 2 questions now. This and okay, either of the 2 we will do. Let's take this one. If A1, A2, A3 be in arithmetic progression with A6 is equal to 2, then the common difference of this AP which maximize the product A1, A4, A5 is basically what you are given is A. Let's say that for the AP, it's the first term is A and the common difference is D. So A6 is equal to A plus 5D is given as 2, right? So we'll write what A is equal to 2 minus 5D. This is the relation. Okay. Now which thing we need to maximize? A1, A4, A5 needs to maximize. So let's write it in the terms. A1 is A, A4 is A plus 3D, and A5 is A plus 4D. Let's substitute the value of A in terms of D. So what we are getting? 2 minus 5D. 2 minus 5D plus 3D. So this will be become 2 minus 2D only. Minus 5D plus 3D. Minus 2D and 2 as it is. 2 minus 5D plus 4D. So this will be left as 2 minus D only. Now, either you can go for the extended product rule to differentiate, or you can differentiate by opening the brackets. Okay. I'll go with the extended product. A1, A4, A5 is given, so I'll differentiate it with respect to D. So what we'll get? The differentiation of the first minus 5, 2 minus 2D, 2 minus D plus differentiation of the second, that is minus 2, 2 minus 5D, 2 minus D plus differentiation of the last and first two functions as it is. This is extended product rule. We can use for three quantities in product form. So this is how we'll do it. Now we need to simplify. There's nothing left. Okay, we need to simplify. So what we'll get? Minus 5 times 2 to the 4 minus 2d minus 4d minus 2d plus 2d square. This is the long questions calculation wise. Okay. Then minus 2 as it is, 2 to the 4 minus 10d minus 2d plus 5d square plus minus 1 common, and we'll get 2 to the 4 minus 10d minus 2d plus 5d square. Is it the same? Did I do any mistake here? 2 minus 2d, 2 minus d, 2 minus 5d, 2 minus d, 2 minus 5d. Oh, sorry, this is 2 minus 2d. Sorry. So this will be 2 to the 4 minus 10d minus 4d minus 4d and minus plus 10d square. Okay, and this ultimately has to be equal to, like, okay, let's simplify it further. Take the minus out, so we'll get minus as common 5. This is what, 2d square into 10, 10d square minus 60 into 5, minus 30d plus 20 plus 5 to 10d square and minus 12d plus minus 24d plus 8 plus 10d square minus 14d plus 4. Equate equal to 0. 10d square, 20d square, 30d square. This is 30d square, 30, 54 and 14 minus 68d, 20, 28, 32 plus 32 is equal to 0. 15d square minus 34d plus 16 is equal to 0. Now we need to find the d value here. This is kind of lengthy questions. Okay, I'll leave this question here. We'll discuss the last question once. Okay, solve this question. We'll discuss the answer in the next class. We'll solve the from here. You need to check this. You'll get two values of d, say d1 and d2. Okay, now this is the only calculation is left. So what you need to do is you need to double differentiate the function and check for d1 and similarly check for d2. If it is greater than 0, sorry, if it is less than 0, then maximize. This will be your answer. If it is less, sorry, you have to check for both. You cannot say which one is positive, which one is negative. Check for sign. Okay. If greater than 0, then minima. If less than 0, maxima. This is of our interest. This is it. Okay. So whichever gives you less than 0, the value will be your answer. Okay. Solve it. I'll discuss this in the next class. Now let's just look at the question. We're left with 4 minutes. I want to show this question as well. Okay. So here we are given the area in square units of the largest rectangle ABCD whose vertices AB lies on the x-axis and CD lies on the parabola y is equal to x square minus 1 below the x-axis. You need to find the area of the largest possible rectangle ABCD whose vertices A and B lies on the x-axis and C and D lies on the parabola y is equal to x square minus 1 below the Okay, so I'll just simply draw and tell you the process. Please try this question at home as your homework. And this is very easy, but I'll just brief you how we'll solve it. Okay, so the step one is draw the parabola. Y is equal to x square minus 1. So the it will get 0 at minus 1 plus 1. So by simplicity, this is our parabola. Y is equal to x square minus and y is equal to x square minus. Okay. Step 2. The rectangle has its vertex on the x-axis and two vertices on the parabola. So please keep in mind such type of questions always involve symmetry. So draw a rectangle. This is A. Oh, sorry. I've drawn it wrong. Since the vertices on the x-axis now, so the rectangle will be somewhat like this. Okay. If this is a point A comma 0, this will be minus A comma 0. Symmetry will always be there. Okay. And if these are the points A comma 0, can you tell me what are these points? A comma A square minus 1. This point will be minus A comma A square minus 1. Okay. Done. Now up, it's simple. You need to maximize the area, right? So area will be what? If I talk about this side, this is 2A, right? Minus A 2A, and this side is what? A square minus 1, right? So the area will be what? 2A times A square minus 1. You need to maximize the area, dA by dA. So that will get 2A cube. So this will be 6A square minus 2. No, it's simple, like it's done here only. 2A cube 6A square minus 2 equal to 0. A is equal to plus minus 1 by root 3. Check for double derivative. So double derivative is what? D square A by dA square is what? 12A. Okay. So this will give us what? A is equal to minus 1 by root 3. For me, is less than 0. Sorry. Okay, I am left with just 1 minute. Basically, you will get A is equal to 1 by root 3 as the value. And the question is asking for the area. So area will be what? Area will be 2 by root 3, 1 by 3 minus 1. This will be 4 by 3 root 3. I hope you are getting it. Sorry to rush in the last moment. I just wanted to show this question basically. That how do we solve such geometrical problem? There will always be a symmetry most of the time. Mostly 100 always. So draw your figures accordingly. Okay. So in today's class, we talked about tangents and normals. Then we talked about monotonicity, and then we talked about extent. Now another part is remaining Rolle's theorem and LMT that we'll discuss in the next class. Okay. The time is up. Sorry, maybe I could not. Okay, fine. We'll continue in the next class. Thank you for being there. Good luck. We'll talk again. Thank you.